Okay, so if you have solved the problem, I didn't mean to discourage you, but you are mostly wrong. Because this problem is not as straightforward as the problem for a path or the chromatic polynomial that we found out in the previous video for a complete graph. This problem is slightly different. Not only is the problem slightly different, it will confuse you to a state that you will end up solving it, but your answer will be incorrect. I'll tell you what I'm trying to point out. So look at this first node. In lambda ways you can color it. Look at the second node. You can color it in lambda minus 1 ways. Look at the third node. You can color it in lambda minus 1 ways because this fellow is colored with lambda minus 1, the previous vertex. Now the last vertex can also be colored with lambda minus 1 ways is what you would think, but that is wrong. Why? Think about this. This person here gets a color, this person here gets a color. The first vertex and the third vertex. If they both are different, then you have lambda minus 2 choices for the fourth vertex. If they both are the same, then you have lambda minus 1 choices. You see what I'm saying? The number of choices for this last vertex depends on what was the color of the first and the third vertex. Now you cannot solve this problem simply by putting lambda minus 1 or lambda minus 2 here. Right? You should do something else here. What is that something else? Let us think about it patiently. First node, second node, third node, fourth node. First is definitely lambda, second is definitely lambda minus 1, third is again lambda minus 1, but fourth we have a problem. But then, let me use a technical term, there are two mutually exclusive possibilities here. What do I mean by that? So, assume I am taking attendance in my classes and you are my student. And I now want to compute the total number of days I have handled my class, which means total attendance. So what I can do is I will look at total days I have handled the class in your presence in my class. Assume you are this front bencher. I see you in my class. 30 classes, you are there in my class. 10 classes, you are not there in my class. So I have handled a total of 40 classes, which is 30 plus 10. 30 with you, 10 without you. Is there a third possibility? None at all. These two are mutually exclusive possibilities and the sum total gives me the total possibilities. Similarly, analogously speaking, think about it. The total number of ways in which you can color this C4 here is the total number of ways in which you can color with the first and the third vertex. These two vertices having the same color. Case 1 and case 2 is these two vertices having different color. Correct? Let me look at the case 1 here. Case 1 is, let me write this down, the same graph, and I will say these two, vertex 1 and vertex 3, have different colors. Now, isn't that equivalent to simply you putting a edge here? I'll write a dotted edge because dotted edge denotes that there is no edge here, but I'm considering an edge because I'm considering the case when these two vertices have different colors. So what is a chromatic polynomial of this? In how many ways can you color this graph with lambda colors? That will give you some possibilities. But then there is also case 2. Case 2 would be case 1 is the number of classes I have taken with you in my class, right? Similarly, the case 1 is number of possibilities where these two nodes are of different colors. That is case 1. Case 2 would be number of possibilities with these two having the same color, with you not being in the class. Correct? So what is that? You put 1, 2, 3 and 4 vertices, join 1, 2, 3 and 4, and finally 1 and 3 should be identified as the same vertex. Only then you are forced to put the same color. Think. This is the place where you might get confused. 1 and 3 should be of the same color. So what I will do is, instead of writing a square like this, a C4 like this, I will identify 1 and 3 as the same vertex and have on either sides 2 and 4. In how many ways can you color this with lambda colors will be the question then. What is the chromatic polynomial of this will be the question. This captures the possibility of 1 and 3 having the same color. The answer for this is same as the answer for C of this path with 3 vertices. So, the question of in how many ways can you color a C4 with lambda colors is equal to 2 mutually exclusive possibilities. Total number of ways in which you can color this C4 with a diagonal representing these 2 vertices will have different colors, plus the total number of ways in which you can color this simple path with 3 vertices. So what's the answer for this? What is the answer for this? Gives you the answer for this.